You guys remember a couple of weeks ago when I was raving, just so much positivity for this Bqh2 Extruder. And yeah, it's a great extruder. But like I said in that video, it's a little hefty. I feel like it could be lighter. It is all metal, and maybe that's where the weight comes from. But still, I'd like to see a lighter weight direct drive extruder so we can print faster. And that's what this thing is right here, the Overheats Extruder. Now, it doesn't have a hot end attached to it, so it's not a fully, contained unit of extruder hot end all combined, but it is a very lightweight extruder with this small round stepper motor and a planetary gear set in there that drives the whole thing. So I did make a video about this already, about open source and how this it isn't playing very nice with open source. It's technically open source and it's released under a non-commercial license, but this guy's making money off of his non-commercial thing, and by locking it up non-commercial means that other people won't be able to make any money because they can't resell it, and so they can't improve it. And so he was kind of making it so that he's the only one that can make improvements on it. And this version 1 that I have in my hand really does need some improvements, but version 1.5 seems to have made some of those improvements. So yeah, definitely if you're going to get this, get version 1.5. Check out the link in the description to the Thingiverse Reddit for version 1.5, because version 1 Thingiverse is what pops up. And also, if you go looking on like AliExpress or eBay or whatever for the Overheats Extruder, you're likely to find version 1, which is what's being flooded in the market from all of the cloners. Okay, so also in that Thingiverse link, you'll find the official resellers. And one of those resellers happens to be Triangle Labs, and that's a tragedy. Triangle Labs, I don't think there's another company, team in China that's done more damage to 3D printing as far as cloning goes. Like, they are shameless. They will just straight up Control-C, Control-V your product. And to be working with them in an official capacity, I don't think that was a good move for the creator of this extruder to have done. But the extruder itself, pretty interesting. Definitely the lightest weight extruder on the market, which means that we can make prints happen more rapidly, and that's always a good thing. So let's dissect this thing and put it through its paces. I won't be able to speak to the materiality or the quality of the official version of this. Hopefully, if you pay, a little bit more money and get it from a Western, supply chain where you can trust the how things are made. You're not just buying a clone, lowest bottom dollar, lots of corner cuts were taken. Hopefully, if you pay the big money, you'll get good quality. But even this clone here looks pretty good. The metal here for the spider, I think that's what you call this part. Yep, there you go. That's the spider. It's nicely. It looks like die cast aluminum, so it's not machined, but I don't think it needs to be. There's bearings on every surface, and that includes the surface where this goes into. So there's bearings at the front and the back of this axle, and then the axles that hold the ring gears here, or I'm sorry, these are the planetary gears. These as well are bearings. So we're not going to have any bushings, which is really quite nice. I like to see that. That's a good attention to detail. But I'm looking at this. These are nylon. These are nylon. These are not metal on metal. So these will wear out. It's just a matter of time. And they do not, in the clone, they did not come lubricated. So you're definitely going to want to lubricate that. Speaking of which, friend of the channel, Michael Hathaway, makes this Tink Seal product. Really incredible stuff. He's got this like chemistry background, and he started to give me some hints about how he has to you basically have to blend oil and water together. And how do you do that? It's crazy chemistry in order to make this stuff. And he's given me hints of what's in here, and it's blowing my mind. So this stuff is no joke. An awesome product, especially for lubricating plastic on plastic or plastic on metal. So for all of your 3D printed parts that are going to be functional, you guys should get a hold. This is a big tub of it. I think he sells smaller tubs as well. So I'll put the link to his eBay listing down in the description. Just one of those nice, homegrown American businesses where he figured out a really great recipe for something that we can all find kind of useful. So I'm going to lubricate this up with some Tink Seal off camera, but let's finish talking about it first. You guys see this big old hob gear? That is quite large. And I thought when I first saw this that it was not a Bondtech knockoff because it's oversized, even though it's clearly, basically just a larger version of a Bondtech. I was like, oh, Bondtech didn't do that, so this must not be a knockoff, but I'm wrong. Bondtech absolutely made the larger axle size of this gear. So this is a Bondtech clone. Bondtech does charge a lot of money for this, and maybe if there were no clones, Bondtech would not be charging such a large amount. I don't know how that works, but it is poor form to be just straight up copycatting, especially if this is another Western designer. He really should have reached out to Bondtech, gotten their blessings, maybe sent them some royalty payments for using their design. They came up with this. And Bondtech is a team of engineers that are doing really top-notch work, which is something I would love to say about this, but I just don't see that. Now, the reason why the planetary gear set is just so special in this extruder is because it gives a very large gear reduction in a very small and lightweight package. And that means that we can use this tiny little pancake stepper motor here and get all of the torque or all of the strength that we need from a much smaller motor, which means much lighter weight in your direct drive. So you're not throwing around heavy weights whenever your printer's moving around. So that's really attractive. And the reports that I'm getting from a lot of different random people are telling me that this stepper motor overheats because it is just so small, and you are just like running it like crazy to spin, whatever the gear ratio is in this. Here, I'll flash it on the screen, the gear ratio. So that's just working really hard, spinning a lot, which makes a lot of heat. And you also have to, because you want to have that hold torque, they're really running this thing through its paces, using it to its full extent. This extruder, or the stepper motor on this extruder, has a much easier job, much easier time of it. So this overheating issue is an issue. And if you want to put some sort of a ducting or heat sink on this motor, that's going to add to the weight. So I don't know that whoever designed this did their own research and development. Like, did they really test this to failure and really just see how hot this motor gets? Because if this motor is getting really warm, it could potentially melt the plastic that it's bolted to. I don't have the confidence in this being a finished product like I would have the confidence in the Bondtech here. So got the Slice Engineering hot end on there as well. So this is a really, just top-notch, like a team of smart engineers. Like, you got like 4 really capable engineers battling it out, to figure out the best product that they can make. That's what this is. That's what created this. Whereas this seems more like a hobby project, and it's only cool because of the planetary gear set. And they know it. That's why they've named it the Orbiter. All right, so this is the unit that I'm going to be testing today, and I've tried to make it as lightweight as possible using off-the-shelf components. So I started off with a knockoff E3D V6 hot end, or I should say heatsink. And basically I just cut the end off of there. You can see hacksaw marks and everything. So I cut that part off. I ground it smooth with a file, and then I just drilled out and tapped the top portion to receive the threads here for that. You can see here that I've ground the bevel into the part here, into the throat that's being used to mount to the extruder. So that bevel is needed in order to really clear the hob gears as this throat comes with that nice squared top. It's going to collide with the hob gears. So no bueno, and you can see that that's how the original creator intended you to use this. So so I did that. And the other thing to talk about is the fact that the H2 extruder has the gear which sticks out the side of it. And this allows you to manually cycle through when it's working. I've got this thing over tensioned, but I talked about that the gears get bound up. Oh, okay, there we go, broke them free. So you can manually cycle through the filament by spinning that gear with your thumb. There's no such way to spin the motor here. So all you can do is release the tension on the door and manually force the filament through. So it's just kind of a nice little detail. I don't know how useful it is. I prefer this. It's kind of nice to have that ability, but really not that important. So I might be able to make this lighter weight still. I am using the aluminum heat block there, versus the copper heat block on the Copperhead and on the Mosquito product as well from Slice Engineering. Now, the copper is going to have superior performance for retaining the heat and getting good melt to happen with your filament but it comes at, so where do you want your performance? Do you want it in the melting of the plastic, or do you want it in the weight savings for, to prevent ringing? So it's a trade-off there. But yeah, so the point is I've made this as lightweight as I really can. Let's even remove this part right here. I don't really want that. I'm not going to use it. So this is going to weigh in at 186 grams, and that's pretty lightweight, you guys. My favorite here, my current favorite, the Bqh2 Extruder. This is an all metal extruder, so almost nothing plastic on this except for the wiring, the like clip here for the connector, and this silicone boot, but the silicone is super high temperature. So yeah, this will stand up to a lot of temperature, and it's really more robust because it's all metal versus the plastic here. But it still comes in at a very respectable weight, which is 225 grams. So if we throw this back on the scale and we add 6/4, we're getting pretty close to the weight there. I think if I throw this component back on there, yep, look at that. So get yourself 6/4 and a thing, and you can get an idea for just how much weight that's being saved. And that is, it's substantial, you guys. That's quite substantial. That will definitely affect the ringing, the part quality with the ringing or the ghosting. In comparison, let's look at the super nice engineering behind the Lgx extruder here, with the same wiring, the same cooling fan, all that, all the components. I'm trying to compare apples to apples. Comes up to 302 grams. So this is way, way heavier. You guys, clearly not designed with weight savings in mind here. All right, guys, I've run quite a few tests, and let me show you what I figured out about this extruder. So first of all, it's been sitting here for a few minutes. The extruder motor, so the stepper motor, is just ever so slightly warm to the touch. Room temperature 27 degrees, but the stepper motor here is slightly warmer than room temperature, and I'm putting this thermistor on it, and it's reading 33 degrees. And the result of running all these tests is I figured out the maximum speed is a feed rate of 315 millimeters per minute. That's the feed rate of the filament going into the extruder. That's not the measure of the filament coming out of the extruder. So you guys can see I've got a black Sharpie mark there, marked exactly 100 millimeters down from the entrance to the extruder itself. And we'll just show you guys the maximum speed here. There we go. And in fact, that one didn't quite make it, but that's because you saw it was having to drag the extruder across. This is a little bit of a resistance there, having to pull from this side. So I'm counting that good because the other test that I ran at 315 millimeters per minute, it actually worked out okay. But that is just the limits of what this thing can handle. And if you do the math, 315 millimeters per minute of the 1.75 millimeter filament being fed into that pops out the other end at basically 158 millimeters per second travel speed if you're printing 0.2 millimeter layer height, 0.4 millimeter layer width or line width. So that's the 0.4 millimeter nozzle, prints at 0.4 millimeter line width. So if you figure that's your line width and your line height, then that max speed. So in other words, realistically speaking, you're not going to ever get this thing above like what, 175 millimeters per second? I mean, unless you have a really fine nozzle on it, but for most of us printing with a 0.4 millimeter nozzle, you're stuck below 160 millimeters per second travel speed. So the whole point of making a really lightweight extruder is to be able to move it around really quickly. And when your speed limit here is dictated by the strength of the extruder motor, I think that the weight of the Bqh2 extruder being a little bit more, if your machine is stiff enough, like this one, you could potentially, the weight penalty might not be such a bad thing when this gets you a little higher speed and being all metal and all that. I'm going to make that extrude again, another 100 millimeters. We'll do this like 2 or 3 times here real quick. All right, that's 300 millimeters of filament that I just fed through there. And let's stick the thermometer on there, or thermistor I should say. Yeah, 50 degrees, you guys. And that 50 degrees was reached with a motor current of 800 milliamps. So you could certainly crank that up higher and get it even hotter if you wanted to, but this poor little stepper motor is really just being run for all it's worth, and it gets hot. That's uncomfortable to touch. I've purposely used the same hot end with the same hot block and the same nozzle as the previous tests on the Bqh2 because I'm trying to compare apples to apples here. But I could have upped the performance by putting a, what is this, a mosquito, not mosquito, this is the Copperhead Heatsink from Slice Engineering. I have the nozzle, the heat break, throat, whatever, and the hot block. And why would putting a Copperhead heat break onto the thing make a difference? The answer is because heat creep is a heck of a problem. So we can see temperature currently reading 46 degrees Celsius, and that thermistor is stuck right there on the fins, somewhat close to the, here, let's stick it in the first fan even. So pretty close to the hot end, to the actual hot block. And so if the outside of the fins where the air is blowing are 46 degrees, imagine what the temperature inside of this all metal throat are in there. So the filament could be getting soft before it reaches the melt chamber and dragging along the walls of this, which creates more resistance that the stepper motor then needs to overcome. So I'm absolutely sure that you could achieve higher speeds than the 315 millimeters per minute that I'm currently getting. Probably you could put a faster, more noisy fan. This one seems to be doing okay, but you could really blast a lot of air to cool those fins on this E3D knockoff heatsink and yeah, get that cooler. Yeah, so there's lots of options. It's not an end-all be-all test. PLA probably feeds through the nozzle faster and easier than PETG, so your speed limit's going to be probably slower if you're trying to do this with PETG. I mean, I guess for my just regular normal printing on my Delta printers, which are pretty much speed demons, I'm printing at 150 millimeters per second. So this could maybe supposedly just barely handle that with PLA. And I almost forgot to mention just how difficult it is to get filament loaded into this thing. So loosening the spring here so I can open the lever pretty easily, and I just can't find that that nozzle, you know, that heat break. I just can't find that. It's so difficult. So to load this thing, I actually fully unscrewed it like so, and then stuck that through by eye. There we go. I think that's good enough. There we go. I don't know why that won't go in. Come on, there we go. Yep, there we go. Okay, fine. And then thread it back down. So that breech loading, all that, is just, it's not good. But that's only a problem with version 1.0. Version 1.5 has fixed that filament path at the expense of losing the metal filament path. So you will have problems with abrasion resistance if you're printing with carbon fiber impregnated materials, glass fiber impregnated materials, or even wood fill materials. So the metal is nice if only the path would flow. So the 1.5 is going to be better for flexibles. Version 1.0 is going to be better for abrasion resistance. And follow the link, once again, in the description to the Thingiverse Reddit for version 1.5. And I encourage you guys to read it because there's going to be a lot of rebuttals to the criticisms that I had in this video. And, you know, you can be the judge. I think my criticisms are valid, but he makes a lot of good points in that write-up as well. Let's get back to these Bondtech knockoff dual hob gears for, you know, dual filament feeding. That's faux pas to me. I think it's really poor form because, to the best of my knowledge, that's not an open source component from Bondtech. But even if it is an open source component from Bondtech, he's using that open source component in his design and making money off of Bondtech's creation. And then he's locking up this as a non-commercial open source thing. So if you want to go try to make money off of his creation, so he's making money off of Bondtech, but then he's not letting you make money off of his creation if you can come up with a better way to use this than what he created. Okay, so the Bqh2 Extruder has a similar gear ratio of 7:1, and these stepper motors are actually pretty similar in size, just different form factor. This one's square, this one's circular. But the Bqh2 was able to print a little bit faster, was able to just push that filament out just a little bit faster. So yeah, all in all, I'm going to say that the edge goes to the Bqh2 Extruder. Also, it's all metal, so there's durability and heat resistance for printing in a heated chamber, and the integrated hot end design is just really clean. This doesn't even have a hot end design attached to it. But it is by far the lightest weight extruder on the market, and even though the stepper motor does get hot, stepper motors can handle the heat. They really can. So probably don't want to go much above what I'm running it at, 50 degrees. Getting up to 60, I think 65, 70 degrees is what the write-up at Thingiverse tells you not to exceed, because then the stepper motor starts to melt the plastic that it's mounted to. Of course, the stepper would be fine, spinning even at 150 degrees Celsius. So, if this was a metal creation like the Bqh2, then it wouldn't matter that the stepper is getting hot. It could be almost boiling hot. You can print with it very quickly. You can move that printer very rapidly and not suffer too many consequences. But we're not all just trying to print as quickly as we can. And in fact, there's a lot of reasons to slow down your print. And if you're going to slow down your printing, you'd probably be better served with a lot of the aspects, the other aspects that you'll find from a really high quality designed extruder like the Bondtech Lgx here, with the Copperhead heat break, hot block, and nozzle. But this is your speed racer for sure, because of the elimination of unneeded weight. But it's hiding kind of a dirty secret, and that's the fact that it doesn't handle the whole hot end at all. And so in bolting a hot end, you're going to add more mass because it isn't an elegant integration of the hot end to the extruder. You're going to add mass that you don't need to. So all in all, I've come up with a pretty svelte solution that I showed you guys in this video, but the other solutions that are out there are masking or they're adding some weight that they didn't need to add just to bolt to this universal sort of mounting platform that the creator has come up with. Going forward, I would like to see him come up with version 2.0 that maybe integrates either a metal filament path with the really good filament loading for the so I wouldn't have the problem getting the filament in there. So metal, so it doesn't break down or it's abrasion resistance when printing with carbon fiber or glass or whatever. But also the other option is to have a sort of removable PTFE liner in the filament path, so if it does get worn down, you can just put a new PTFE friction-free liner in there. And that friction-free liner of the PTFE tubing would also mean that the extruder, you'd be able to push just a little bit more filament out, having lost that friction. But I think the most important thing for the creator to do is to get the blessing of Bondtech for using their technology, the dual hob gear technology. Anyway, thanks to these wonderful folks. These are the Patreon supporters that keep me making videos like this. So without these guys, you wouldn't have this video to watch. That'll do it for this week. Thanks for watching. See you next time.